everyone, and welcome to Migrating .NET Core Applications to Red Hat OpenShift, provided by Kairosoft, Red Hat, and StoneDoor Group. My name is Andrea Alexander with StoneDoor Group, and I'll be your host for today's event, along with Jack Sosowski from Kairosoft. In today's event, we'll demonstrate the Red Hat OpenShift Container Platform, show you how you can leverage its features, and explain why it's replacing standalone servers and VMs for hosting .NET Core applications. Our instructor is CJ Meidlinger, who is a senior consultant at StoneDoor Group. For those of you not familiar with StoneDoor Group, we are a Red Hat Apex partner specializing in DevOps transformation. We work with companies of all sizes to implement best practices using Red Hat solutions. As part of our service offerings, we have two items that may be of interest to those attending today's session. The first is our OpenShift Container Platform Accelerator. This service provides the subscription and services necessary to implement an OpenShift Container Platform. In our Accelerator engagement, our consultants conduct a thorough analysis of our client's current infrastructure, application workloads, and their desired future state of application offerings. From there, we will create and execute an implementation plan that establishes a new OpenShift cluster, provides a migration path for existing applications, and delivers a runbook for the creation of greenfield applications. We do provide all the subscriptions needed as well as consulting services to ensure you successfully implement OpenShift. Key areas improved through the implementation of Red Hat OpenShift include reduced complexity, modernized applications, shared accountability, and improved collaboration. This service has been a very successful engagement with our clients who are looking to eliminate redundant expenditures, modernize application workloads, and increase velocity to roll out new applications. The second item I wanted to bring to your attention is our complimentary trial of OpenShift. Available at our website, you can request a fully licensed and configured 3-node OpenShift trial environment. You can find out more about StoneDoor Group and our offerings at stonedoorgroup.com. At this time, I want to pass it back to Jack Sosowski, who's going to provide a little bit more information on Kairosoft.
Thank you, Andrea, and thank you to our audience for joining us today. Kairosoft Technology Corporation is the trusted government IT solutions provider. As a top-performing GSA Schedule, SOUP, and SLSA contract holder, Kairosoft has served as Red Hat's master government aggregator and distributor for more than 14 years. Working as strategic partners and through a robust ecosystem of value-added channel partners and system integrators, Kairosoft delivers top-tier Red Hat solutions to federal, state, and local government agencies, as well as the education community, supporting the public sector mission to prepare for the digital future and modernize approaches to IT through the application of open source solutions. Now, Andrea will go over a few important details for today's webinar.
Great, thanks, Jack. You guys, just a few housekeeping items. If you're experiencing any audio issues, you can dial in using the toll-free number provided on the screen. That's 1-888-788-0099, and our webinar ID is 929-3828-0860 with the password of 540831. If you do need assistance, please contact a member of the StoneDoor Group technical support team at webinar@stonedoorgroup.com, and our team members are standing by ready to assist. During the presentation, we ask that all participants submit questions through Zoom's Q&A feature. You can find this panel on the bottom of your screen where it says Q&A, and just note that this is different from the chat feature. Our instructors will collect and respond to questions submitted throughout today's presentation. For those interested, we are recording today's event. We'll be sending out links to all participants for access to the event recording and presentation materials. If you have any questions, we encourage you to reach out to us at letsdothis@stonedoorgroup.com. And thanks again for joining us for today's event. Kairosoft and StoneDoor Group have teamed up to provide a series of events to enhance your knowledge and skills with Red Hat solutions. We have a 3-part series of 1-hour workshops on best practices for implementing Red Hat's core technologies, including Satellite, Identity Manager, OpenShift, and Ansible. In our previous event, we discussed how to set up the proper RHEL infrastructure. And then following today's event, we're going to host our final workshop on June 11th, where we cover replacing legacy automation scripts with Ansible. And we hope you're able to join us for this final series. Jack, I'm going to pass it back to you so you can talk to the group about the CPE credit offerings.
Great, thanks, Andrea. Kairosoft is pleased to offer 1.2 continuing professional education, or CPE credits, to those that attend today's webinar through our partnership with the National Association of State Boards of Accountancy. In order to qualify for the credits, you must be actively listening and watching the webinar and answer at least 3 of the intermittent polling questions that will be presented throughout the presentation so we can monitor active attendance. Continuing professional education describes educational activities that assist individuals in achieving and maintaining quality and professional knowledge, skills, and/or services. Many organizations require that employees attain a certain number of training hours a year, and CPEs can often be used to meet these requirements. For more information on the CPE credits we are offering, Kairosoft CPE sponsor NASPA, and the submission process, please click the link on your screen. If you meet all of today's requirements, you will receive your certificate of completion within 2 weeks. Back to you, Andrea.
Great, thanks, Jack. You guys, at this time, I'd like to introduce our presenter, CJ Meidlinger with StoneDoor Group. CJ is a senior consultant at StoneDoor Group, where he helps clients migrate applications to the Red Hat OpenShift Container Platform. So CJ, I will pass it over to you.
Great, thanks, Andrea. Assuming everyone can hear me okay. My name is CJ Meidlinger. Just to give you a little bit of background of my experience with OpenShift. I've been in the IT industry for a little over 20 years. Started off with a small outfit doing one of those jack of all trades kinds of jobs, where I was a consultant, a trainer, and also administrator for the local site, so systems and networks. Did some time at IBM for 17 years, working with a lot of application lifecycle stuff, provisioning, orchestration, which evolved, as many of you are aware, into cloud. And cloud has taken a definitive turn towards containerization. And so kind of rode up through that transition with IBM, joined StoneDoor Group a few years ago, and got plugged into a lot of their outreach as far as containerization and cloud native applications are concerned. So did some time as a Docker trainer, haven't done that in a while, but in addition to that, I'm a consultant by day and work on OpenShift clusters. So that's kind of where I'm coming from. And today's demo, has been said a few times, and hopefully you are aware of this, is migrating .NET applications to Red Hat OpenShift. So the purpose of this demo is to demonstrate how we can take your standard sort of .NET Core application that might be running on a standalone server or VM or some other non-orchestrated system and migrate it over to OpenShift to take advantages of many of the things that OpenShift has to offer. So why are we moving to OpenShift? There are three basic areas: the containerization aspect, cluster platform, and CI/CD. Containerization is simply taking an application and bundling it with all of its dependencies. And so it's an isolated process on a system. So unlike virtual machines where you have abstracted hardware and an entire operating system underneath, the containerized application is very lightweight. So that's an attractive feature for a lot of folks that are working with applications, not just .NET, but any application really. In addition to that, the containerization is very portable as well. So the runtime is the containerization engine. And what we've seen is that unlike porting a VM from one place to the next, if you guys have ever tried that, one of the most basic things you run into is the hardware address on a NIC, right? Do you keep it or you generate a new one, that kind of stuff. So all those little things that come into play when you're moving a VM or cloning a VM don't come into play in a containerized world. The second feature of OpenShift that we're going to highlight here today is the clustered platform. And so with a containerized application, you can just go ahead and spin up your container, using a Docker engine or Cryo or any of these other containerization daemons. But all that gives you is a running application. It doesn't give you high availability. It doesn't give you, automatic recovery from adverse events, those sorts of things. So introducing that containerized application into a cluster allows you to leverage a lot of the services of the cluster itself. So in addition to resiliency sort of features like high availability, the clustering platform will often have logging, aggregated logging metrics that are available, and that's the case with OpenShift. And with the latest version of OpenShift, we even have some service mesh capabilities with Istio, and those are pretty exciting things to add to this containerized application deployment world. And the third thing, and this is not specific to OpenShift, but CI/CD, so continuous integration, continuous delivery. So you'll see in the agile world that application development is embracing this, whole hog, and having automation through your development process, through all the tests and security tests, unit tests, whatever, and into a package that's made available to your ops teams is one of the things that's basically required in today's software development world. So although this is not specific to OpenShift, OpenShift does provide a handful of ready-to-go tools that allow you to implement CI/CD immediately without a lot of sweat and tears building it out. So the assumptions that we have for this demo are that the customer is running a .NET application on standalone servers or VMs. So if you're migrating from Kubernetes, you have some other Kubernetes distribution besides OpenShift, and you're migrating to OpenShift, you're not going to see much of a difference. So OpenShift really is just Kubernetes. It's the Red Hat enterprise version of Kubernetes with the Red Hat add-ons. And so this demo is really keeping in mind the person that's new to that world. So, and also that you're facing certain challenges, because if you're not facing the challenges, why migrate, right? Because there's always going to be some sort of cost to that migration. And some of the challenges that are common we run into are multiple deployment environments. So again, if you compile an application and you want to deploy it somewhere, it is .NET up, right? So .NET or .NET Core can run on Linux using the .NET Core runtime. I think older versions might use like Mono, the Mono framework. You can run it on Windows, lots of different versions of Windows servers, right? Windows, and you'll forgive me if I'm not up on my Windows versions, but Windows 7 or Windows 10, whatever you got there. It's been a while since I've been on a Windows platform. So these multiple deployment environments, not only you got versions of your operating systems, but different configurations or different deployments. So let's say you've got a Windows server and this .NET app is sitting on there, and it's also, that server happens to be also running another application. And you've seen this if you've ever deployed applications in an enterprise environment before, that what you deploy onto that server can affect the other things that are running on it, whether it's something as simple as consuming RAM that application number one expected to be there and is not there because another app is consuming it, or libraries that conflict, things like that. So when you deploy into one server, you might think, hey, this is always going to work on Windows 10. You deploy it on the next Windows 10 and all of a sudden it's broken, right? So the multiple deployment environments is a huge challenge. And again, containerization on its own takes care of a lot of that. There will be some issues with the application, depending on how deeply an application hooks into the hardware or into the operating system. But general, web-based applications, cloud-based things, the containerized version of those tends to avoid those multiple deployment environments. Difficult to scale. So again, just the challenges of having multiple environments, well, scaling is the same thing, right? So if you want to add multiple servers and you've got a clustered environment, I'm thinking you're going to have some sort of configuration on each of your servers that needs to tie in together. And that effort to scale out, to add a new server to the cluster, has to be coordinated with whatever. You might have a master server that maintains the state of the cluster. So you make some updates there, and then you have to add this new VM. And that VM may have a slightly different configuration than the previous one that was deployed, or previous 7 or whatever. And what you'll see is there will be hiccups. Yeah, it's not the end of the world, but the difficulty in scaling is a pain point for some folks, really depending on what the original architecture looks like. So with OpenShift, the scaling is built in. It's an orchestrated platform. You put your containerized application into it, and then you can set, the scale. You can run multiple pods, and we'll get into what a pod is here in a little bit. A pod is, just for now, we can think of a pod as a container. It's not exactly that, but we'll if you've got multiple pods running, you need to scale up or scale down. That's as simple as running a command on OpenShift. So scaling is a challenge that OpenShift meets. And then slow to update with new features. Because of the overhead with the multiple deployment environments and difficulty of scaling, you tend to take a more cautious approach to updates. With a containerized app and CI/CD, and this is where the CI/CD part comes in, a lot of the tests can be automated, and when you have that level of automation, that you can implement newer features more rapidly. And again, that's CI/CD is not something that's specific to OpenShift, but with OpenShift, you have a bunch of out-of-the-box tools that you can use to really implement it and get going fast. Okay, so the goals for the demo here will be to containerize a .NET Core application. And we're going to deploy that .NET Core application into OpenShift. And we're going to leverage some of the OpenShift services and application management. So we'll see like how to scale it up, scale it down, some basic stuff, nothing out of the world. And then we're going to show you how to trigger a new build and deployments from a code update. And that takes us into a demo. So if you give me a second here, I will transition over to the full desktop. So here we have the OpenShift Desktop. On the left, you see the navigation panel. So here's Home, and each one is a grouping here. So you'll see when you mouse over, you get the little arrows, so you can see different things there. So Home has where you can list your projects, status of the cluster. I am currently logged in as a non-privileged user, so I'm not going to see anything here. But if you're an administrator on a cluster, you will see sorts of metrics and things here. The catalog is where we will find out-of-the-box templates for things we can deploy, and we're going to use one of those in our .NET demo. I like to use the catalog items because they're repeatable. So you guys go home to your own OpenShift, or if you decide to use a StoneDoor Group Accelerator cluster, then you can basically do the same thing without having to go find the same code or whatever. Workloads. As an OpenShift operations guy, you might be seeing some of these from day to day. You'll be working in this area, but even as a developer, if you get into troubleshooting, you'll have to poke around and look at these things. And I didn't really have that as part of the demo. Sorry, I do my demos kind of freeform, but if we have time, I'll show you how to do some debugging with a pod, because that's actually pretty cool. Your networking stuff, you've got some services, routes. We'll look at those. Storage, we're going to be using an ephemeral .NET applications. We're not going to be persistent storage, but you can see there's a storage facility built into this, and we can leverage lots of different storage providers. So if you've got your OpenShift running in Amazon Web Services, you can use an S3 bucket and provide that to OpenShift. You can provide block storage to OpenShift from various providers as well. The one that's most tightly integrated with OpenShift is Gluster, and it's Gluster is a standalone storage product, but there's a OpenShift sort of version of that we call OpenShift Container Storage, OCS, but that's really just Gluster underneath. That one works really well and provides both file and block storage. Builds are for your software builds. Monitoring is where you can see the logging output, and again, if I was admin, we'd see some metrics and stuff down here too. So this is your brief sort of navigation tour, and let's go ahead and start doing some stuff here. So I'm going to go ahead and create a project, and I'm going to call this project .NET Demo. and I've created it. Okay, so right now it says I'm in .NET Demo. It's the only project I see available to me. Just so you know what a project is a logical grouping of OpenShift resources to which one can apply access controls. It's probably a more detailed definition than that, but that's a great way of thinking about it for folks that are new to OpenShift. So when I go spin up my application, I'm going to be creating some resources. You might want to call them objects. I slip up and call them objects because I worked a long time in the Corba years, but they're called resources in OpenShift. You'll spin up resources, and each application will have multiple resources supporting it. So it's really broken out into different pieces and allows you to really, finely or granularly manage your application. So now that we've got a project in which we can deploy our application, I'm going to go over to the developer catalog and pick an application. Coincidentally, the .NET stuff are right here at the top. But if I scroll down here a little bit, you will see there are other things here. You've got Elasticsearch. There's some JBoss. Lots of good JBoss stuff. More JBoss. There's some Jenkins, MongoDB, Nginx, Node.js, PHP, and so on. I'm not going to read them all off, but you get the idea. So there's a ton of these that are available, and we're going to use this one here, the .NET Core example. So let's go ahead and say create. And the template is not completely hard-coded. The template will be parameterized in most cases. I think pretty much every single one of them that's provided with OpenShift with the default installation does have some parameters you can set. You don't have to if you're building your own template, so you can make it to where the application will be deployed with all of its resources the same way exactly every single time. That is an option. If you have an organization that has strict rules on certain parameters, let's say your .NET builder, let's say, we're using .NET 2.2 here. If for some reason you believe that 2.2 doesn't meet your organization's security requirements, or maybe you have a coding standard, simply just like, hey, we need to be all in the same build level, that you can take away this option. You would just clone this template and then hard code that into whatever your organization needs. So just to show you that there are like a ton of these things here. We can point to context directories. We can set GitHub webhook secrets for pulling from a private repository, etc., and so on. There's just a bunch of things here. We're not really worried about that. We're just looking at getting this application deployed into a container and then working with it. So you can see here the Git repository is github.com, Red Hat developer, S2I.NET Core -EX. EX just means example. So what we're going to do with applying this template is going to scroll down here, go ahead and create, and it should be rolling here. So I'll pull this up on, look at the pods. All right. So right now, what this template deployment is going to do is it's going to grab the build image, right? So we have a container image that's up on the Red Hat registry that is designed for building .NET images. We have a ton of them. You can build Java images, Node.js, etc. There's just a ton of them. So we're going to be combining the container image for building and runtime with the code from GitHub, and we're going to bring those in, and then the template will tell OpenShift what sort of OpenShift resources it needs to create. And we'll take a look at that a little bit later. So right now the build is running. When the build completes, and in a little bit here, you'll see another pod fire up. You'll get a deploy pod, and then you'll see the actual running application. So while this is running, we can click on this again. So this is a pod. A pod is simply a wrapper for one or more containers. And we're not going to get into multiple containers today, but you could have multiple containers running in the pod. They would share the network space. It's handy for inserting authentication. So you've got an app that's running that needs some authentication. You could either build that authentication into the application itself, or you can just shove a authentication container into the same pod as a sidecar, as we call it, and send the traffic to that authentication container, which will then forward the traffic to your application container. But then they would both be riding in the same pod at that point. So this is still running. If I click on the pod, we can see pod details up here. So this thing is chugging along. It's using some memory. It's using some CPU. File system, that's it's going to be all ephemeral. If we want to look at the environment, you'll see some of the parameters that we put in there. And logs is an interesting one. So right now, you see it's installing all this stuff. So I forget what command this is, but it's right there. Starting packages. I guess it's the user exec assemble. At any rate, so this is all from a Docker file, right? So if you're familiar with Docker files, here's your base image. Image registry, OpenShift image registry, SVC. So that's the internal registry. The OpenShift designation here is the project namespace, which holds all of our build images and stuff. So we got a label, we set some environment stuff. There's your .NET demo. That again was from our template. GitHub, here's our build source. That's again from our template. So this stuff from our web form gets passed into this Docker file and becomes part of the build. Scroll down. After everything gets built, it's okay, go ahead and push this, this completed application container image into the registry. So that's what we've got going on there. And again, if you're familiar with Docker deployments, you'll see this kind of stuff topping the blob. Go back to the list of pods. And let's see, we've got two of them that are completed. So let's go ahead and show those. So here is the build pod. That's the one we were just looking at. And then we have a deploy pod. The deploy pod actually deploys the application. So this is our application pod running right now. So we have taken some code, we've containerized it, and we've deployed it onto OpenShift all in one fell swoop. Now, of course, that's the easy way of doing it using a template, but you got to start somewhere, right? Let's see. So if we look at the logs here, here's the application running. So how do I access this thing, you might ask? And the answer is in the various resources. I think this might be a good time to see if I see the, let's see, copy login command. Oh, here we go. Give me a second. It's going to require authentication. One of the login command that it's going to provide me includes an authentication token, and so I got to re-authenticate here. Display token. So I'm just going to copy this command, and that'll let me log in at the command line. There we go. So I'm currently using project.NET demo. If you want to see some of the stuff from the command line, the web interface, and you'll have to forgive me a little bit, since I'm a consultant with OpenShift and I work with it every day, you might imagine I use the command line a lot more than the web interface. So I'm not sure if there's a good way in the web interface to show you what the template looks like. So I'm just going to do it from the command line. So here we are using project.NET demo. All the commands will start with OC. The OC, get all. And what this will do is it actually doesn't get all. It's just kind of it gets most of all. So get all will show you a bunch of the resources that are running in this project. So you can see here, we've got some pods that are running, or pods that exist, let's say. Because 2 of them are completed. The build and the deploy are done. The app is running. This ready, that tells you how many containers are in the pod. So since the build and deploy are completed, we have 0 containers that are ready out of 1, which is assigned to the pod. So you'll see it's 1 of 1. But if you look at Elasticsearch, I think that's a 2 of 2. There might be a 3 of 3 out there that's part of the OpenShift default thing. But so, 1 or 2 are really what the common ones are. If you need a sidecar container, you'll see a couple of containers in a pod. We've got a replication controller. We've got a service. So service is how we communicate with the application when we are within the cluster. This, because containers are ephemeral, they will come and go, right? So when the when the pod is fired up on a node, you might have, I don't know, a dozen different worker nodes in your cluster. The address spaces for containers and pods are split up by node. So if the container or the pod goes down on a node and OpenShift spins it up as part of its self-healing on a different node, you'll be guaranteed to have a different IP address. So how do you get your services to talk to this application if it keeps moving around like that? Because it can move around. There's nothing stopping it from doing that. Is that we have this service address. So the service address has a permanent address, and then it has endpoints. And through the use of Kubernetes labeling, it keeps track of all these pods. So when the pod spins up somewhere new, you will see the new IP address for that pod attached to the service. So as long as your other services hit this IP address or the service name, right, because we do have service discovery, you can always communicate with this application, no matter if it scales to 20 pods or down to 1, doesn't matter. All those will be added to the service. As you note, this 172 address is non-routable, so if you need to reach this application from outside the cluster, you use a route. And skip ahead, here's the route resource down here. And so we can take this route, which is fully routable here, and let's see, where is, let's pull up this one. We'll plug it in there, and there's our application. All right, so coming back to the command line, we have a deployment config, which is a deployment configuration. And this is the thing that tells us, where to go to get the code, which image we want to use, how many pods it needs to spin up, etc. The build config tells how to build it. So I'm sorry, let me back up then. This particular deployment config is not going to have the code. So the build config will have the code location. And then once the container is built, this will have the built container location as part of it. So it's going to deploy that. The build is simply an instance of the build config. So the build config says, here's how I build it. If I need to build it again, let's say I make a change, I'm not going to change my build config. I'm not going to say go to a different repo all of a sudden. I'm not going to say use a different base image perhaps. I just need to do another build. I would say, okay, go ahead, start build, and point this build config, and it would generate a new build. And the version of the build is kept here in this last numeral here. So .NET example 1 means it's build number 1. And you can see that same thing is carried through into the pod name. Okay? Image stream is a logical sort of description of a set of container images. So you could have lots of different container images of different versions, right? So you got your application and you got version 1, version 2, version 3, version 4. You can refer to all of them with an image stream like this, .NET example. That is the name of the image stream. We could just make a reference to that. And we can take a look at the details of that too. So what I want to do now, though, is look at the template. And this will be in a couple different formats. So see, get templates. Now, if you remember, but we said that the build image was pulled from the OpenShift namespace. In this other command, OC get all, if you don't specify the namespace or project, it'll just default to whatever one you're in. So my current context is .NET Demo. Since I want to get the templates that are in the OpenShift namespace, I would say OC get templates minus n OpenShift. And I'll type that through a pager. And you can see here all the ones. And a lot of these will map to the templates that are in the catalog. There's tons of stuff in here. I often get clients that say, let's, can we create a template together? And they've got like a blank file. And I said, no, let's start with one that already exists that gets you like 90% of the way there and just modify it. So the one that we looked at, let's see, grab net. So .NET example is the one we used, right? So if I want to see what that looks like, I would just specify the name. So this follows the pattern, like OC just tells my shell that this is an OC command, go to Hat OpenShift. Get is a verb, so you say get or delete, describe, different things like that. The type of resource. This type of resource is called a template as opposed to a pod or build config or a service or a route. This is a template. And then you give it the name of the template. In this case, .NET example. And then, got the little zoom thing covering my bottom right. Let's flip this up. And if I do this by itself, it'll simply list that one. So there you go. To see the details of it, you have to specify a certain type of output. You can do JSON, and I'm just going to let this one scroll because I'm not going to use this. But you can see that that's what it looks like in JSON format. And you'll see here the parameters that were exposed in the web interface when we deployed this, right? Another option, which is tends to be a little finicky on white space, but certainly more human readable in my personal opinion, is YAML. And what I'll do is I will put that through a pager and show you what it looks like inside there. All right, so here we have a template. And the template will contain multiple different resources. So in here, we saw that a route was created. Here is the route and name, application domain. These are things, these are parameters or variables that were set, in part by the parameters that we supplied to the template when we deployed it. Here's the service. All right, so this service will keep track of our endpoints and direct the web traffic to it. So here's a port. You can, if you want to clone this template and modify it, maybe 8080 is not what you want to use. Maybe you want to use 8088. I don't know. Again, different organizations may have different standards, and it's pretty easy to modify these things to meet those standards. There's your image stream resource. So that gets created. Here's your build config. So here in your build config, it's output. So after I build my container image, where does it go? Well, it goes to this image stream tag, the image stream that was created by the other resource there, and we just gave it latest. So we can update that to give it a different tag if we like. Context dir, that's the directory within your Git repo, and then the repo information itself. So the information that we provided for GitHub, that all went there. I'm not going to go through all these, but you get the idea. Source strategy, triggers. These are kind of cool. So this is in our build config. So the build can be set to trigger automatically. So if we see an image change, we can trigger a new build. It helps with our automation. Make sure though that automated build gets tested before it goes to production. Ideally through say a CD pipeline, but as long as it doesn't automatically go through, you won't be super disappointed. And here's your deployment config. So replicas 1. I'll show you how we can modify that on the fly. You can either edit the YAML or use a command and so on. We've got a readiness probe, a liveness probe. That's for health checking. It's kind of just built in and so on. And here are the parameters. So if you want to add a parameter to this template, you just follow this format. Give it a description, display name, a name, whether it's required or not. And this value is just a default value. So when we pulled up that form, you saw some of the things were already written in. So .NET example was already there as the name. We just left that in place. .NET 2.2 was there. And we should also see that Git repo in here. There you go. Oops. So there you go. So that's what the template looks like. I'm going to take a second here, grab a swig of water, and check the Q&A. I'm not seeing any questions yet. So if you have questions, feel free to drop them into the Q&A session. Like I said, I'll grab a quick drink of water here, and then we'll continue the demo. Okay. So now that we've seen what this stuff looks like from the command line, we've seen the application running. Let's come back to the web interface here and look at some other things that we can do. So deployment config. Right now, status is 1 of 1 pods. If I want to bring that up to 2 pods, there's a couple different ways we can do it. If you're thinking automation, you might want to use command line. So we would say something like, OC, get DC. There are some shortcuts like this. DC is a deployment config. OC get, RC is replication controller. OC get SVC is your service, and so on. Okay, so DC name is .NET example. I can say OC scale replicas equals 2. DC in .NET example. Actually, I'll use this format. And for do that, though, let's go ahead and show you another command here. So see, get pods. Those are our pods. You can use the watch command, but there's, let's just use that. So we're going to watch this. There's another form that you can use. So that is there. And let's go ahead and scale this to 3. Let's make it a little more hard. You know what? Let's go crazy. Let's go 5. And now that it's scaled, you see over here, this thing jumps in, containers are creating, and so on. And as they get spun up, since they're just pulling from the already built image, right? We scaled the deployment config. We didn't do anything with the build. We don't go through the build process again. We just pull that standard container image we built. and spin up more copies of that. Okay, so now you see that you've got several of them running. So not quite ready yet. Oh, he's ready now. And so the application now has 5 pods, and we'll see what that looks like over here. So if we go to pods, and you see a bunch of pods. So now let's look at the service. OC get SVC, .NET example. So I don't have to specify the name of an object either when I do this. If I say OC get SVC, you see it does that. If I do pods, it lists all the pods. Now, if I do, -O YAML to get the YAML output, if I don't specify a pod name, I will get the YAML for all of these pods. So if you only have one object, it really doesn't matter. And I think it'll work the same way for describe. So if I say OC describe CC, there you go. And so here's our service, again, with the service address that we can use. And here are the pods. So 2 more are listed in our endpoints. And again, if we scale up and down, those will continue to be tracked by the service address. Okay, so let's take a look now at the scenario where we might want to trigger a new build. And because this is a Git repo that is read-only for the purposes of the template here to get people started with OpenShift, we can't make a change to it, but we can show you, we can imagine that we make a change. And if that change is made, how would we trigger a build on OpenShift? Well, there's like a dozen different ways that can be done. You can have your CI/CD pipeline, tooling do that, whether it's Jenkins or Bamboo is a popular one for people that are migrating from .NET, right? Because Windows houses, they'll have those sorts of Windows type tooling, right? Bamboo, Octopus, that kind of stuff. So those integrate well with OpenShift. What else? GitLab has its own runner system. It's actually very, very elegant. I like that one a lot. Actually, I like them all. They all have unique characteristics and are fun to work with. Keeps things interesting. But at the end of the day, each one of those things, when it triggers a new build, is just interacting with the API, Kubernetes API, to say, go ahead and start a build. So if you want to use one of those, they'll have their plugins. You can there's a plugin for Jenkins, OpenShift plugin, a Kubernetes plugin. You install those, and then you can build in your Jenkins pipeline a trigger to go ahead and start to build, and it's going to hit the API in your cluster. Well, these commands, the OC commands, they hit the API too. So this is going to be just showing you how to go ahead and trigger a build using command line. And we'll go ahead and, okay, so we're still watching the pods up here. So in order to trigger a build, we're going to look at the build config, right? So OC get build config, OC get build. And again, the build is the one that has the version number. So we're going to trigger the build config here and just go ahead and let it run. So OC start build, and there's a bunch of these too. There's like OC new build if you want to create a new build config and things like that. A lot of tooling for getting things up and running. It just can't really cover it all in an hour. It's more like a 5-day class. But OC start build, and then build config .NET example. And when that happens, we should see in our pod window up here, the build pod launch and start doing its thing. There you go. So we just launched a new build pod. It is version number 2 here. and we can follow the logs. I showed you in the UI where we can look at the logs. So here's our build pod. If I click on the build pod and then click on logs, we can see it chugging along. So it's getting the image it needs for the build, and it's going to download the source code, etc. We can also do that from the command line over here. So let's see, get builds. And these are things, the logs are actually dumped into a lot of the tools like Jenkins or Bamboo or whatever. So I don't do this one every day. So let's go ahead and let's see, logs, -f is follow. And let's see, oh, I'll do the build pod, there we go. Let's see, logs, -f. And here's the build pod. There you go. So we are tailing this. We are just going to continue to watch this as it runs, and when it's completed, you'll see a new deploy pod, and then all 5 of these guys will switch over to version 2. So that's again crunching along here. If I come back to the web interface, you see it's the same thing. While it's running, we can take a look at a couple of other things that are really cool. We've got the terminal. Okay, so we don't get terminal here, but we can, I don't know if I can do it from the command line. So that guy's running. Let's do, let's see, see, get pods, see RSH. So you can RSH into a pod and poke around. Let's do this one. So now I'm inside that pod. See what kind of tools we got. And let's see, we've got netstat. Okay, no netstat. Anyway, so I'm actually in the pod. If you want to find out, let's see, IP, if config, nope. So here's a little bonus thing. Not a lot of OpenShift guys know this or do this, but you can actually get this information from proc file system, proc TCP6. So there's your connections. You have to convert it from hex. I have a script on a different machine that does that for me. But that's one way of running netstat that when netstat's not there. All right, so container creating. So you got all these like version 2s here. So they're going to be up and running. And the last thing I want to show you, and Andrea, I'm probably going to go over maybe like a minute or so, but this is kind of cool. Let's do a debug session. Let's see, get our deployment config. And let's say we went to version 2 and everything cratered, right? Not that we want that to happen, but it happens. In order to figure out what's going on, you can launch a pod called a debug pod, which allows you to spin up the container up to the point where the application itself gets launched. If the application craters, you can't get logs from that pod. The pod dies. So you have this like catch-22. It's like I want to see what's going on, but when the pod keeps crashing, I can't RSH into it. I can't get logs from it. What do I do? Again, we've got these great development tools as part of OpenShift. OC Debug is one of them. So OC Debug.NET example, and you'll see a debug pod fire up in our pods window up there. So here we go. Here's the debug pod that's running, and that's what I am now interactively working with. So, and it tells you, hey, the starting pod debug command was container entry point binsh c blah, 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 blah. If you don't see the command prompt, try pressing enter. So that tells me what I can run to like launch the application if I like. So from here, let's say, let's exec bash. Now we could try running it, see what happens. Let's copy this down to here. And again, another purpose of this debug pod is not simply to be able to launch it and watch it. I can actually mess with the environment. So if your application is drawing from the environment, let's say you've got a debug level set as an environment variable. You can go ahead and modify that, then run your debug and get more meaningful information out of it. In the meantime, so it's running application, blah, blah, blah. So this should look very similar to any of these other pods that we have running. As far as their output, let's see. I'm going to kill this for a second. Let's see, get pods. Let's see, let's see logs, and we'll just grab this one. And there you go. So this log output is basically what you see on standard out. You know, kind of a 12-factor app, cloud ready. You know, you want to be logging to standard out so that your aggregated logging system can scrape it, et cetera, et cetera. Okay, so let's jump back to the slide deck. And so that was our demo. And these are hopefully your takeaways. Oh, I forgot to touch on the .NET Framework app. So we do need to, if you have .NET Framework, a couple other .NET formats, they do need to be ported to .NET Core. .NET Core is the only version of .NET that's supported on Red Hat. And hopefully it's easy using the STI and OpenShift provided build images. The tools and services, you saw some of those command line tools. There are GUI representations of those as well, so you can click around if that's your preference. And obviously, it's an excellent platform in implementing CI/CD pipelines. We didn't get into that too much detail. I listed several that you can look into. And hopefully you take my word that OpenShift is pretty much CI/CD ready, because that's what we do on the job. Here are some references for different things. The key one here, well, obviously the StoneDoor Group one is super important. But the other items here is look at the last one. If you do have a .NET Framework app, they have this portability analyzer, which you can run against your app to help you identify what needs to be updated to make it .core compliant. And with that, Andrea, I'm going to hand it back to you.
Sounds great. Thanks, CJ. So you guys, just a quick reminder to everybody, we are hosting another event on June 11th. That's going to be the third and final event of our three-part series that covers best practices for implementing Red Hat's core technologies. So June 11th, we'll be covering replacing legacy automation scripts with Ansible. And then just a quick reminder of the service offerings that we shared earlier. We've got our OpenShift Container Platform Accelerator engagement. And so that's a brief engagement where we help you all implement OpenShift and provide some consulting services along with that. And then if you're interested in our complimentary access to an OpenShift lab environment, please, you can check out on our website. That's a link that we do have in the presentation, or you can reach out to us at the email address you've got on your screen, which is letsdothis@stonedoorgroup.com. At the close of today's event, you're going to see a survey poll, and we ask that you take a minute to answer a few brief questions to help us improve our future presentations and events. And just a quick reminder, we will be sending out a link in the next day or two that's got the presentation as well as a recording of today's event. So you do have that to take away as well. So I just want to thank everybody for your participation, and we hope you all have a wonderful day.